Hello everyone, I am Manas Patra from DJ Sangvi College of Engineering. This is our mini project for the subject microcontroller and application. So this project is done by me myself, NIKHIL SONI and Nishit HINGU. So the topic of our project is to display data in a GLCD using 8051. So in the introduction part, so our project what does is it represents data graphically in the GLCD that we have interfaced with 8051 microcontroller. So the rest of the circuits will be explained by Nishit in the later section. So now let us see what are the components used in project. So the first we have used the GLCD display that our data will be displayed over there. Then 8051 microcontroller, the few capacitors that are listed here, and resistors. The crystal frequency oscillator use has a frequency of 11.0592 megahertz, and the rest of the components are listed here. And the next part will be explained by Nikhil now.
Thank you, Manas. So let's have a look at the working principles. So first, we'll have a look at how GLCD works. So we can see on the image that the GLCD is divided into 16 equal parts, the left column and the right column, and each column can be selected individually and each part can be processed individually. So here are the given combinations which we can give to the CS2 and CS1 chips so that we can use different parts. So as you can see, to use page 0, we can give 0 and 1, so respectively. So in this way, we can access individual parts. Now let's have a look at the pseudocode for this particular program. So the pseudocode is divided into two parts, that is the main part and the display part. The main part shows the basic flow of the program, and the display function will fill the columns, that is the bars, accordingly. So let's have a look at the main part first. So we first initialize the value of all the bars of the chart in an array. We then initialize the GLCD, that is the graphical display. Then we clear the complete display so that if any backlog data is present on the display, it gets cleared. Then we call the display function by passing the bar values in it. We pass at a time so that 4 bars get displayed on the screen. Then we produce a delay of 100 ms. Then we repeat these steps continuously. So now let's have a look at how the display function works. We first select the left half of the display. Then we initialize page to 0. Then if the page is odd, we skip that part so that spacing is given to the bars. Then we check if the value is less than 50. If the value is less than 50, then we fill just the left part of the bar. And if it is greater than 50, then we completely fill the left part and then we fill the right part until the value is achieved. Then we increment the page and repeat these steps continuously. Now we till page 8 because the GLCD has only 16 pages and they are on the left and right. So we have to do this for only 8 pages. So if the page is equal to 8, we stop the program and return to the main function. Now the code and the execution will be shown by Nishit HINGU.
Thank you, Nikhil. Now let's see the code and the execution of this program. So let's first run the program. Then I will see the connections and everything. So we can see that we are getting variable graphs changing through time. So now let's see the connections first. So this circuit gives us VCC and ground for our circuit. VCC and ground, which is connected to our 8051. This is the oscillating frequency given to XTAL1 and XTAL2. The reset circuit is this, and this is the interfacing with the GLCD. So we can see that port 3 is connected to the data pins of the GLCD. So we'll get the GLCD through port 3. The port 2 are the control pins which will control the GLCD, which is selecting the page 1, either the column 1 page or column 2 page, then the read write signals and everything. So now let's see the code. So initially this is written in C, embedded C. So we have included the header files, register 51, and this all. It is easier for us to write the code. Here we have assigned the port pins to the variables rs, rw, e, cs, cs2. So it is convenient for us to refer it in the future in this code. This is the code for delay of m seconds, which will be k seconds for a frequency of 11.0592. So this is the command which will to give the command to graphical LCD to either print or clear or anything, which will be done by this. We can see that rs, we are giving command to the port, so our rs will be 0. Here we are writing the data to the port, so we can see that rs is 1. The other or values are same. Then the initialization will initialize the GLCD, setting its cursor to the first point and everything. Then this is the function for clearing all the values in the GLCD. So all the data which is there initially, which we need to clear it first. So this is the code for. So we'll make each column data 0 through this code. Then this is our main function display, which will take an variable, which will take an array, which is val, which we can see here. This is the int val array which we have declared, and it has 10 arrays, sub arrays, so which have 4 values, which will decide the value of this graph that we get here. So we'll pass each of these 4 values one at a time in this for loop. So here it will take this array, it will initialize everything. The CS1, CS2, it will select the column either 1 or the second section, first section or the first section of the second section of the page we need to select, and according to it, it will then display it will only darken that much columns which are less than the value of the array which we are sending. So this is the display function. Whose algorithm was explained earlier by Nikhil. We have just written it in a embedded C language. So this was our code. Now the further part will be explained by Manas Patra.
Thank you, Nishit. So in the conclusion part, so our project displays the data in a graphical method, and which can be used to further applications for a music equalizer or to display data in a graphically. So in the future scope, we can see that our data can be converted to a set of our audio file can be converted to a set of data, and which can be fed to the microcontroller, and the data when the beats are of the music are high, the data can be displayed in the GLCD in a graphical form, as it was shown in the previous section. So in the application part, we can see that our project can be used as an audio equalizer. We can use data to visualize them in a graphical form, and for statistical analysis. So the references used over for this project are linked over here. So that was our project for MCA subject. Thank you.